Hello, welcome to another briefing. I'm just going to turn the volume up a little bit. So we're going to start out with the satellite image per usual. So we go back here. This is going back about 36 hours. So we go, this is early yesterday, and then yesterday you have those high clouds from this weather system passing us to the south. You can actually see the circulation on that. If you pay attention right off the coast of Central California, see that circulation. There's your upper level low pushing through. There's that storm system. You can see it's mostly focused to the south of us. So you go through this loop. Yesterday you have some high cirrus clouds sort of spill over from the main precipitation clouds to the south. You can see that thing sliding by, going into the Great Basin. Here's this morning. Getting some dry breaks. We had a nice little dry break in the Bay Area about an hour or two ago. See right in here. Nice break in the clouds, sunny skies. But right after that, there's a next batch of clouds. This seems to be mostly stratocumulus. Sort of a, looks like maybe sort of a marine layer developing, but I think there is still some high, perhaps alto cumulus that's spinning around that upper low, those upper dynamics. Let me play this back again. Yeah, there's something, some kind of little vortmax or little shortwave spinning over the Central Valley right now, it seems, and that's infecting some mid-level clouds. See that little feature over here. It's really important to start out these things by looking at the satellite, being able to identify what these clouds are, why they're there. If you have a basic understanding of the current conditions, you're gonna be better able to understand any kind of computer model guidance you look at. But it's really important to have this understanding of the basic conditions and understand what you're looking at, and it provides more insight too. I know a lot of people just like to jump straight to the numbers, but this is really helpful in terms of really identifying what's going on right now, and then how that is going to translate into the future. Anyways, I'll get off my soapbox and I will show the sounding. Actually, I'm gonna do that later because I get the feeling some people don't really like that because it's really technical and they might disengage. So this is sort of technical as well, but I mean, if you've been watching these videos for a while, you kind of have an idea. But I always tend to explain. This is the 500 millibar chart. This is basically the, if you're looking at about 18,000 feet up in the atmosphere, where a lot of these this weather gets steered because that's halfway up the troposphere where the weather, most of our weather occurs. So you're looking here in between the warmer columns and the colder columns, you have where you have a lot of winds, where you have these tightly packed height lines, the black lines here. You have the jet stream. All right, that so we just kind of like, I like to pick out here what the jet stream is doing. This is the main flow. I'm going to talk about some cutoff lows that we have. So there's that main flow of the jet stream that I just drew. However, not all weather systems stay attached to the jet stream. Here's a little cutoff low. This is probably what's going over Central California right now. Or no, sorry, this is... Okay, I didn't realize this was a future projection. I didn't want to do it like that. Okay, sorry. I'm gonna have to redo this. Bear with me. But this is what's going on right now. And then, so you can see kind of ridges and troughs. And the ridges are where you're going to have usually warmer weather. The troughs you're going to have usually cooler weather, sometimes rain, depending on how these things set up. And you can see you have this is going to become a cutoff low, but I'm not going to get too much into that right now. This is just what's going on right now with the jet stream. You can see a cooler pattern over the west coast, right? That's why we're having our cooler conditions across much of the Bay Area right now, because that trough is in control. You go back the last few days, you can see here kind of weather system go by earlier in the week that brought us some pretty good rain, and then that ejected, and then we dried out just briefly, and then we have this current system passing to our south, not bringing a lot of rain because the right front quadrant for that system is further south. That's where you have most of the dynamics to link up with the moisture and bring rain. We're getting more of the north end, the back end of that system with this one, but we are seeing cooler conditions, more clouds, a little more wind. Let's go ahead and talk about the wind. Show the wind, as a matter of fact. This is the station plot from the National Weather Service. All sorts of different stations, a mix of airports, official stations, personal weather stations in some cases. And you have pretty good winds, gusting in the teens for most areas here, gusting 23 at SFO. Yeah, you have pretty respectable west winds throughout most of the Bay Area here. Yeah, west southwest in some areas, sort of northwest along Point Reyes because of the terrain. That's pretty typical. So pretty good onshore westerly flow. And take a look at the Mount Tam camera here. Let's look at the last 3 hours. See some patches of fog this morning with those low marine clouds, and then you have this layer of fair weather cumulus. You can see there's not a lot of instability because these things aren't developing that much vertically. I'm going to take an earlier frame here so I can show this. See, in these clouds, they have vertical movement just till about here. And this is where the cap is. The cap is when there's an inversion where you have warmer air above colder air, and that keeps air parcels from rising because the air parcel is going to become cooler than its environment here, so it loses positive buoyancy and then it starts to sink. If you have an environment where you have really cold air aloft, you have a lot of instability, then in that case the air parcel would keep rising, and that's how you can get really big thunderstorms when the conditions are right, because these clouds will keep growing until they hit basically the top of the troposphere, and then you can have really heavy storms. That's what we had back in February. We had some hail because we had updrafts carrying these particles way up into the clouds, and then you get ice. Anyways, you get the stronger the updraft, the bigger the hail, generally. Not always, but anyways, I don't want to get too much into the specifics of that right now. But yeah, that's pretty much. Let's just look at the. Check my battery real quick, and then we'll look at the projection, the European model. Take this with a grain of salt. That's model guidance. And troughing kind of persists, cooler, breezier weather. Doesn't look like a lot of rain just because these things aren't oriented to bring much rain. Could get a warm up Friday into next weekend, and then I mean, I'd say Friday, maybe Saturday, and then by next Sunday, there could be another weather system getting organized, bringing us some cooler weather. I guess making up for all that heat in March. We've had a pretty chilly April. Might be a pretty chilly start to May as well. I won't get too much into that. The rain chances don't look really significant with these. It's going to be mostly just a continued cool, maybe cloudy pattern. My next briefing, I'll address this further as we get closer to this um, potential next weather system, and then we'll be able to talk a little more in depth about that. So I hope you enjoyed this. I hope you got something out of it. Thank you for watching, and I'll see you next time.